Open shortest path first. OSPF. You see, this is a routing protocol developed by using very popular open standard algorithm called SPF. This SPF, shortest path first algorithm, you have it in various places. Shortest path first. Even when you go to some new place, you use Google Map. Why? Because it is finding shortest path for you. Shortest path is one option. Toll-free path is another option. So you will have different options. Shortest path is the default option. It will show you the shortest path to the destination that you want to go. So this algorithm, shortest path first algorithm, which is also called as binary tree algorithm or Dijkstra's algorithm. Dijkstra is the man who proposed this algorithm. Based on this algorithm, a routing protocol is developed. And this routing protocol is also an open standard. So they named it as open shortest path first, open standard routing protocol, which uses SPF algorithm. They named it after these two things. One is open standard, another one is using SPF algorithm. So they named this routing protocol as what? OSPF. Open shortest path first. SPF is not a routing protocol, understand? SPF is just an algorithm. Open shortest path first is the routing protocol. Dijkstra, Dijkstra. From that idea, from that algorithm, they got a very good knowledge to develop a routing protocol. Who developed this routing protocol? No one, but all. Meaning it's an IEEE standard. In the internet, someone proposes, someone tests, someone develops, someone corrects it. At last, it comes as a standard. After a lot of people doing changes, it comes as a standard. So OSPF is a IEEE standard protocol. Open shortest path first. See how many RFCs. This is a forum where people do research and see whenever the change happens to the protocol, the number will vary. They give different number. 1989, 10 years after I was born, this protocol was gaining popular. And now still it is very popular. There is no other alternate for OSPF. OSPF is the alternate. ISIS is the alternate. ISIS is another routing protocol popular like OSPF. But they have their own style. Alright, so it's an RFC standard. It's an industry standard protocol in general. Industry standard protocol. With various type of RFCs. Whenever changes happen, they get new number RFC numbers. But not important. what we need to understand here is this is a very important routing protocol. Forget about RFC numbers, IEEE standards. One thing you understand that this is an industry standard protocol, widely used in industry. Whenever you design a very large network, OSPF will always be recommended. OSPF is many times better than EIGRP. Open shortest path first. Now, administrative distance in OSPF, in Cisco for OSPF, is 110. What is EIGRP's AD? Yeah. RIP? Oh. I'm getting from same voice. What about the other person? Okay, so this is a question they will ask in CCNA level interviews. OSPF is 110. Okay, fine. Now this comes under a category called link state. Link state routing protocol. You see, EIGRP and RIP comes under a category called distance vector. RIP is a distance vector protocol because it shows the distance and the direction. Direction is nothing but vector. Distance vector. Distance and direction. Same way, EIGRP will also show you a composite value as a metric with distance and vector. Instead of hop count, EIGRP uses composite value, bandwidth and delay. So that is also distance vector. Whereas OSPF is a link state routing protocol. Based on the status of the link, the cost is auto-calculated. And this link state advertisements helps a router to understand, discover the whole topology. That is why this is a this is a link state routing protocol. Let me explain you what is link state. Important, very important for interview. I've just taken 3 routers. They are connected with some wires. Now, each router will advertise their link status. Each router will say, I have this particular link or many links. I have these links. On these links, these are the networks. These are the subnets, and these are the bandwidths of this router links. On this router, let's say for in this topology, for example, each router has got 3 links, 3 wires, 3 ports connected. So now router 1 will advertise like this. Hey, I got 2 more links. The status of the link is up. The network on that link is this. Subnet mask is this. Bandwidth is this. Because the bandwidth is this, the cost is this. Automatically cost is calculated. And this link state information alone is shared to router 3. Likewise, router 3 will advertise to router 2, router 1, router 2 will advertise to router 1, router 3. This is what called as link state advertisement. Link state informations are shared. Collecting this link state information, by collecting this link state information, every router in its memory build this database, build this map. Say after collecting the link state link state information, a database is built after collecting link state advertisements. Every router now understands the topology in the memory. It has got a picture of the topology now. With the help of this picture, if R1 wants to go to this place, R1 says, okay, I'm here. I want to go here. This is one path. This is another path. Which one is shortest? So it will compare the cost. Based on bandwidth, let's say the cost here is 1, 1 and 1. So if I go this way, the cost is only 1. If I go this way, the cost is 2. So I will only choose to go this way. So it takes this info and put it into the routing table. In the routing table, it will say to go to this network, I should go to router 3. So in the routing table, you get this route. So whenever a packet comes to router 1, it will send the packet this way to go here. Did you understand? So it is this database that gives the knowledge of topology, that gives every router an understanding of which network is connected where and what is the best path, the shortest path. So using the SPF algorithm, on this database, this router 2 runs the SPF algorithm. For each destination, it finds the shortest path. And only the shortest path will be placed into the routing table. Only the shortest path is placed into the routing table. Using that shortest path, the packets are forwarded whenever the packet wants to go to the destinations. This is the reason why it is called as link state protocol. Please understand that EIGRP and RIP, they advertise the route from the routing table. EIGRP and RIP advertise the route from the routing table. OSPF is not like that. OSPF don't advertise the routing table. OSPF advertise the link state information. By collecting link state information, they built a link state database. On link state database, SPF algorithm only finds the best path and puts into the routing table. That's a big difference. Let me put it in Tamil. ரிப்பும் EIGRPயும் நம்மை போல. ஏதாவது கேட்டீங்கன்னா என்ன சொல்லுவேன்? எனக்கு எது பெஸ்ட்னு தோணுதோ அதை நான் சொல்லுவேன். அந்த மாதிரி தான் ரிப்பு EIGRP. பெஸ்ட் ரூட்ல ரவுட்டிங் டேபிள் இருக்கும். அந்த பெஸ்ட் ரவுட்டிங் டேபிள் பெஸ்ட் ரூட்டை மட்டும் தான் சொல்லும் EIGRPயோ ரிப்போ. மற்ற நெய்பருக்கு, மற்ற ரவுட்டர்ஸ்க்கு என்ன சொல்லும்? பெஸ்ட் ரூட்ஸ் மட்டும் தான் சொல்லும். ரவுட்டிங் டேபிள்ல இருக்க பெஸ்ட் ரூட். ஆனா கூகுள் மேப்பை கேட்டீங்கன்னா அப்படி இல்லை. என்ன கேட்டீங்கன்னா நான் பெஸ்ட் ரூட் மட்டும் தான் சொல்றேன். ஆனா கூகுள் மேப்பை கேட்டீங்கன்னா இதுதான் பெஸ்ட், இல்லைன்னா இப்படி கூட சொல்லும். எஸ்டிமேட்டட் டைம் சிமிலர். இந்த 2 ரூட் வழியா போனாலும் சேம் டைம் தான் ஆகும். 2 ரூட் இருக்குதுங்க அப்படின்னா அப்புறம் இன்னொரு ரூட்டை காமிச்சு இது 2 minutes லேட் டிலேங்க. இன்னொரு ரூட்டை காமிச்சு இது 8 minutes டிலேடு ரூட். இந்த மாதிரி எல்லா பாசிபிள் பாத்ஸையும் OSPF அனுப்பும். எல்லா பாசிபிள் பாத்தையும், வெறும் பெஸ்ட் பாத்து மட்டும் இல்லை. மறுபடியும் சொல்றேன், லிங்க் ஸ்டேட் அப்படின்னா என்ன? லிங்க் ஸ்டேட்டஸ் அனுப்புறது. எல்லா பாதைகள், எல்லா லிங்க் ஸ்டேட்டஸையும் அனுப்பிடுவோம். எப்பா நீ முடிவு பண்ணிக்கோ, உனக்கு எது சரின்னு ஏற்படுதோ நீ அதை யூஸ் பண்ணிக்கோ. இதுதான் எல்லா பாதையும், எல்லா லிங்க் ஸ்டேட்டஸும் இதுதான். இதுதான் அங்க இருக்கிற காஸ்ட், இதுதான் நெட்வொர்க், எல்லாம் இதுதான் வச்சுக்கோ. நீ கம்பேர் பண்ணி உனக்கு எது சரின்னு படுதோ அதை எடுத்துக்கோ. தட் இஸ் OSPF. ஆனா EIGRP இப்போ அப்படி கிடையாது. இதுதான் பெஸ்ட் வச்சுக்கோ. அது எனக்கு வேணா பெஸ்டா இருக்கலாம், உங்களுக்கு அது பெஸ்டா இருக்கணும்னு அவசியம் இல்லை இல்லையா? அதான் பிரச்சனை. டிஸ்டன்ஸ் வெக்டர் புரோட்டோகால்ல அதான் பிரச்சனை. ஒவ்வொரு ரவுட்டிங் டேபிளும் தன்னுடைய பெஸ்ட்டை கொடுக்கும். அது அடுத்தவனுக்கு பெஸ்டா இருக்கணும்னு அவசியம் கிடையாது. அடுத்தவனுக்கு வேற கூட பெஸ்டா இருக்கலாம், அது உங்களுக்கு பெஸ்டா இல்லாம இருக்கலாம். அதனால OSPF தான் சிறந்தது. ஏன்னா உனக்கு என்ன பெஸ்ட் நான் தீர்மானிக்க மாட்டேன்பா, என்கிட்ட இருக்கிறது எல்லாம் உனக்கு கொடுத்துட்றேன், நீ முடிவு பண்ணிக்கோ உனக்கு எது பெஸ்ட். SPF இருக்கிறத வச்சு நீ முடிவு பண்ணிக்கோ. So link state routing protocol says I'll give you all that I know, the link state infos, networks. You decide by running the SPF algorithm. So OSPF runs that SPF algorithm on the information collected in link state database. What database? Link state database, LSDB. This is LSDB. What is running on that LSDB? SPF algorithm. For each destination, the best path will be picked up, and that best path alone will go into the routing table. The route that is seen in the routing table only be used whenever the packages need to be forwarded. மறுபடியும் சொல்றேன், ரவுட்டிங் டேபிள்ல இருக்கிற பாதையை மட்டும்தான் ரவுட்டர்ஸ் என்ன பண்ண முடியும்? பாக்கெட்டை எங்க அனுப்பலாம்னு தேடும் போது ரவுட்டிங் டேபிள் என்ன ரூட்டு காமிக்குதோ அங்க மட்டும் தான் அனுப்ப முடியும். டேட்டா பேஸ்ல 1000 ரூட் இருக்கலாம், லிங்க் ஸ்டேட் டேட்டா பேஸ்ல 1000 ரூட் இருக்கலாம், அதெல்லாம் பொருட்டா எடுக்காது. All that is there in the LSDB will not be utilized. The route that is picked up by SPF as the best route get placed into the routing table. Only those routes will be used for packet forwarding to the destination. Okay. So SPF algorithm is the one which picks the best path. Link state database, link state advertisement, these are all the terminologies that you should know about OSPF. So far I have explained to you why OSPF is called as link state routing protocol. And OSPF is a link state protocol with administrative distance of what? 110. What is the metric of OSPF? What is metric of VIGRP? Can someone say? I'm asking metric. What is the metric of EIGRP? Bandwidth and delay. Reliability lang கிடையாது. Bandwidth and delay. Bandwidth and delay. The metric of OSPF is cost. Cost. If someone says cost, a lot of question will come in your mind. Cost. Is it Indian rupee or Omani Riyal or Dubai dirhams? What is this cost? London euro or US dollar or Australian dollar or Singapore dollar? What is this cost? Naira? Nigeria Naira? What is this cost? That's a big question. No? The answer is it's a numerical value. You can set if you want, but if you don't set, it will automatically calculate. It will automatically calculate the cost based on the bandwidth. Based on the bandwidth on the link, it calculates the cost automatically. So metric of OSPF is cost. That is what we need to say. And later you can add cost is calculated using bandwidth. For example, if bandwidth is 10 meg and another link bandwidth is 100 meg, to reach this network 1.1. See, you can reach this network in this path, in this path. Which one has got more bandwidth? Path 2 or path 1? Hello. Path 2. So OSPF will say this is the best path. You know how? It automatically calculates the cost like this. Cost is equal to 100 by bandwidth. So in path 1, 100 by 10, which is 10. Cost is 10 here. In path 2, 100 by 100, cost is 1. You see, lower the cost, better is the route. 10 ரூபாங்க இங்க ஒரே ரூபாய் தாங்க நான் இந்த வழியாவே போய்க்கிறேன் அப்படின்னு எல்லாரும் போவாங்க இல்லையா அந்த மாதிரி தான் always metric is small is better small metric the best metric So router will prefer path 2 because the bandwidth is more. When bandwidth is more, the cost will be less. When the cost is less, that is what the best path is. Any question? See, these are all the confusing portion of OSPF. When I was studying initially, no one was clearly telling me these things. They said OSPF metric cost, OSPF metric cost. Some said OSPF metric cost based on bandwidth. I appreciate it. But still, how? No one explained. Later, when I studied more and more, then I understood. This is the formula. This is the formula it is using to calculate automatically the cost. If the bandwidth is 10 meg, cost is 10. If the bandwidth is 100 meg, cost is only 1 because it's 100 by bandwidth. And bandwidth is written in MB, megabits. So OSPF cost is calculated automatically. But if you will go and tell cost is 100, actually the automatically calculated cost is only 1. But if you go and say, no, I want to consider as 100, then this will become the best path. Why? Here you did not set the cost. Here cost is auto-calculated. Here cost is configured by you. The command is very simple. Go under the interface and say IP OSPF cost 100. On this interface, you did not say that. So it automatically calculates and uses 10 as the cost. Here you configured as 100. Even though the bandwidth is more, router 1 will not use it. Why? Because owner is telling, no, the cost is 100, don't use this. So router 1 says, fine, I'll use this one. Even though the bandwidth is less, it uses this because the cost is low. What I'm trying to say is, if you will set cost, it will override the auto cost. Did you understand this part, Arjun? Prem? Okay. Now this OSPF can support any size network. That is why it is very popular. There is no limit. Any size. என்னங்க சொல்றீங்க லிமிட் இல்லாம உலகத்துல எதுவுமே கிடையாது. Unlimited rice. Some more restaurants in Tamil Nadu, you can see this. I have never seen in Karnataka. In Tamil Nadu, they used to have restaurants, unlimited. But definitely there is a limit. What if that entire anda gunda is empty? They will say finish, go. So even in restaurant, they cook only limited. They cannot have 5 tons of rice. Not possible. Few kilograms of rice they will make. After we finish that, they will say, no, go, finish. We need to close the hotel. If you come 2 times, I need to sell my property. So don't come. You are eating too much. You finish the entire restaurant. So there is limit for everything. How can OSPF be unlimited? Yes, OSPF design is like that. How? You see, it follows a hierarchy. It follows a two-tier architecture. There will be one group of uh, routers. We call it as area, and another group of router we connect here. Let's say approximately 255 routers. Here another 255 routers maximum you can have, and another 255 routers. Right? So we break the big network into small areas for easy management, for scalability. That's why that is why OSPF is very popular. This is the reason why OSPF can be used in big internet. OSPF follows the hierarchy, two-tier hierarchy. And this area which is connecting all other area should always be number zero, area zero. This can be area 1, this can be area 2, this can be area 3. You can have 6, 5, 5, 3, 5 areas. But zero number is only reserved for the backbone. We call this as backbone area. Why? Because it is connecting all other areas. Every area must be connected to backbone area. Remember, every area must be connected to backbone area. Backbone area will act as a transit area, right? Backbone area will act as a transit. அப்படின்னா என்ன? மற்ற ஏரியாக்கள் எல்லாம் இந்த ஏரியாவை பயன்படுத்தி தான் ஒன்றோடு ஒன்று பேசிக்கொள்ள முடியும். உதாரணத்திற்கு ஏரியா 1 இருக்கும் நெட்வொர்க் ஆனது ஏரியா 3க்கு ஏரியா 0 வழியா மாத்திரம்தான் போக முடியும். For example, area 1 routes get distributed only via area 0. It cannot reach the other way. Even if you have one wire connected like this, area 1 and area 3 will not form neighbor. They don't share anything. It's always through area 0. That is how it is designed. Because of this design, hierarchical design, because of this hierarchical design, OSPF is popular. It is highly scalable because of this. Yeah. So we'll